I suppose necessity is the mother of invention. And one of the biggest problems when we're working with a platform that likes to put your videos out there randomly is people might not realize that we're actually working through a process. So with this edition, we're going to add what I'm calling the status stoplight, which allow us to show which stage of our ready set code process we're working on at the moment. For example, when we were preparing in the beginning, we had nothing really going on besides creating a tool that would help us review the code. So we went ready, set, or coding, obviously. Recently, of course, we've been using ready, and we've been in the ready mode. So we're going to simply light up the R on our stoplight and put that on our slides. And when we're set, we'll have the yellow. And finally, when we have the code, will look pretty much like you expect to see when you're at a car racing show, for example, and you're just getting ready, set to drive off. And we'll be putting our status stoplight on our slides as we move through the rest of this presentation. So if you've been following this presentation, you know that we're going through an update of the PyTrack or Star Trek 2020 game to add some enhancements. One of those enhancements, as we previously discussed, was to have a multiple client capability to be able to view a GUI TUI, as we're calling it, or a TUI GUI, I suppose, because text is still going to be the primary display payload. And this time we're still in the ready mode, and we've covered, of course, the normal flows for both our networking as well as for our graphical test, so that we can get ready for doing what we have to do next, which will be looking at our alternate flows, either they be diagnostic flows, error flows, or alternate flows. 3 additional steps that I very rarely see ever considered in any agile process, and sometimes missing from some waterfall processes, but very much a part of what we need to do in our big review. So taking a look at our error flow, we see that maybe something's going wrong with our client, or maybe something's going slow or very wrong with our server. So in order to look at our alternate and recovery flows, certainly our error flows, we're going to come up, as we've talked about before, with our second client being a diagnostic or an administrative client. Now, the diagnostic client will eventually want to be doing things like banning clients or restarting servers or sending logging messages to either the server or the client or both. But for our purposes, all we're going to want to do is at some point in time allow us to test what's going on, keeping in mind that we're going to have time to do diagnostics and admin clients in future sprints or future Agile projects. Eventually, of course, we're also going to want to have some kind of game log that we can both look at from the diagnostic point of view as well as write to, so we can keep track of what's going on as we test our server or servers from our diagnostic, admin, or regression testing client interface to our servers. Ultimately, and this is the important part, if we're going to be testing our server, what we need to do is get a copy of all the data that will be required to bring the server back to a certain view state. Now, there's several problems here. The first being that we have to get more than just a simple view, but more importantly, we're going to have to get a copy of the randomizer that allows the game to play, so that when we begin to have random activities, we're going to have the same random activities. And there are a few tricks and techniques I'll be showing you, from capturing our print display, or flight recorder as we're going to call it, to dumping our data, but more importantly, to capturing a predictable or non-random randomizer that will have enough numbers in there to allow us to consistently test and retest or regression test the PyTrack user experience. So let's take a look at some of our testing problems. And I was surprised, as you might be, that we have some clearly demonstrable test cases that I think you'll find interesting when we look at the code. Certainly, when we're going to be taking our testing or diagnostic client view from our Trek server, but will obviously also impact our Trek client. As part of our ready mode, we did take a look at our network timeout, specifically as it occurs under Python. This tree you might have seen before. It talks about the inheritance relationship of all of our errors. And in this case, we're going to be looking at our OS error and some surprising needs we're going to have to test, for example, when we lose connection for either our client or our server. Let's take a look at that now, because there are some special challenges here that we're going to need to be aware of, certainly, as we begin to wind up our ready mode. So to demonstrate the problem we're going to have when managing our test cases, the first thing we should probably do is update our server, or our run server.py, so as to give us a game test. And that game test, of course, we should be trying something. Let's try putting in a new parameter called timeout, and we'll set that kwarg equal to our number of seconds, of course, to allow us to catch any exception. I mean, absolutely anything we could come up with as E before we print it out as the server failed some way. And then, of course, now we have to go up and update our kwargs to include the timeout. In this case, we'll simply say the same thing if we don't have timeout and kwargs, and otherwise we're going to assign a default time of 0, and that time, of course, will be in seconds. No timeout at all. Of course, the next thing to do would be to use our timeout down here while we're looping and things are true to see if kwargs, of course, the timeout parameter is part of our kwargs. We're going to go ahead and sleep either 0 seconds or whatever we decided the timeout value would be. And therefore, we can now test to see what would happen if we waited 5 seconds before responding to what we've received from our client. The last thing to do, of course, would be to make sure we have the time module imported. Moving to our run client, we're going to want to do the similar type of thing, except this time we're going to want to make sure that if we don't have a timeout, let's go ahead and just arbitrarily say we're going to make the timeout equal to 1 second. Probably not good for production, but it's good enough for testing. And once again, we can always use 0 for seconds. And then we're going to use the set timeout, the exact same number of seconds, on our sock. And because our sock has a timeout capability, we don't have to import the time module. And we do the similar type of thing that we did for our server for our client. Namely, we're going to try a numsec, in this case 2 seconds, before we run our client, or to also report that the client had failed, if it has. Changing over to my PyTrek location, we go ahead and start our server up. And as we expect, we'll see things running. And switching back over to our newly updated UDP ready mode tester, we're going to sleep for our 2 seconds before getting our client failed timeout. Wonderful, which proves, of course, that we see our client failed message. So things could be managed within Python very gracefully. In other words, we keep on looping if we had a timeout or anything else. But over on the server, there's some very strange things afoot, because our program is aborting simply because that operating system error was a type of error that tells Python that it probably shouldn't move on at all. It could be a hard drive failure, or it could be memory failure, or it could be a solar flare, or simply a temporary Wi-Fi error. And even though this error, in other words, we can't send the message out, is recoverable, so since the problem was on our server, the solution is also on our server. As we probably know, all we'd have to do is simplify our main driver to emulate what would be coming in from our command line parameters, setting our timeout once again to 5, but catching our exception as we see here with our try loop underneath our forever loop, so as to allow us to recover from the problem. Switching things around a bit, let's go ahead and put our server into our main idle thread before running our client from the command line this time, seeing our timeout, but seeing ourselves recovering from our error as would expect. Fun fact, take a look at how our port number does indeed change each and every time we send a Z-ping from our client to our server. The one option that comes up here is that We could also be sending a shutdown message from our client, but more importantly, probably from our diagnostic server, so as to begin to shut down, restart, and retest things for any game that we might have running on any server that we might have within our reach. Completing our truth table, we can go ahead and move our exception handling from our client main into our main loop like we saw with our server. And we probably don't want to loop forever because we can get errors very, very quickly. And we can wind up looping forever, even if we're waiting for a few seconds, if the error happens right away. So what we probably need to do is to put a retry parameter in there. Let's, in this case, retry for 3, and then check to see if our retry is part of our quargs. And if it isn't, we'll put it in there as a default of 1. And now we'll set our retry counter equal to 0 and say if retry is less than number requested, we'll go ahead and get things working. And if things fail, we'll add 1 to retries. Otherwise, we should probably simply set retry equal to 0, effectively saying that if things go well, we can continue to try future transactions until things go poorly. That would also be a good time to put in a sleeper, so that we get some time to shut down our server, for example, so that we can test this and not have things just go crazy on us. So at this point, we're going to want to import our time module. Well, let's go ahead and bump up our sleep a little bit to 6 seconds to give the server the time to do the time that needs to do things in time. To see our reception working as we'd expect. Stopping our server, however, rather rudely. Let's see what happens as we test our client. We are indeed seeing that we got our number of tryouts, one being a timeout, and then another being a forcibly closed message, not happening once but twice, which pretty much proves that we are indeed managing our exceptions as we expect. A timeout error, incrementing by 1, and then 2 client failure messages, giving us our total of 3 retries. All is well, at least on this version of Microsoft Windows, because in previous versions, things didn't work nearly as well. Let me assure you I'm quite happy that they're working after my latest update to Microsoft Windows. But your machine and your ability to recover from these type of errors might vary. In other words, you might not be able to as easily manage an exception coming back from any other operating system. So it's always good to try this code whenever you're part of any ready mode.